Hello everyone. In 2020, Microsoft Excel released Dynamic Arrays, which received an overwhelmingly positive response from the community. Dynamic Arrays is a fundamental change to the way formulas work and to Excel's calculation engine. It's an enhancement of Excel spreadsheet language. In this lesson, I will review all of this to you. The lesson will be presented as follows. First, I will demonstrate the behavior of dynamic arrays by some small examples. We will explain specific terms such as array, spill range, spilled range operator. Then we will recall behaviors in older versions of Excel and state the essence of dynamic arrays. To harness the power of dynamic arrays, Microsoft has added several amazing new functions at the same time. They are filter, unique, sort by, rand array, and sequence. We will demonstrate the use of these 6 functions. Then we will introduce the versions of Excel where dynamic arrays and the new functions are supported. In the end, from the perspective of programming languages, we will review the essence of this enhancement of Excel spreadsheet language and the essence of its advantages. We will foresee the impact of this change on Excel users and on the way we build spreadsheets. Now let's start with the demo. Let's enter some random numbers in column B. 1, 2, 3, 4, 5, 6. Now we would like to add 10 to each number of column B and write into column C. It's a very easy task. Traditionally, what we do is in C1 type equal B1 plus 10, enter. Then we copy this formula by Ctrl C, select the range C2 to C6, and paste it by Ctrl V. As a result, we create a bunch of formulas of the same structure with different references. The values are correct, everything is awesome. In 2020, Excel introduced dynamic arrays. We have a new solution for this task. In D1, let's enter equal B1 colon B6 plus 10, enter. We see that the formula filled in the range D1 to D6 with the correct values. How were the values calculated? Actually, Excel first evaluates the result of B1 plus 10, which is 11, and writes it to cell D1. Then Excel evaluates the result of B2 plus 10, which is 12, and writes it to cell D2, and so on. In the end, it evaluates the result of B6 plus 10, which is 16, and writes it to cell D6. So the formula of D1 returns a set of values which are written into range D1 to D6. And the entire range has a border in blue. So when we select cell D2, what is displayed in the formula bar is light. It means that the cell doesn't really have a formula. Its value comes from the formula in D1. Same for D3 and other cells. If we want to modify this formula, we just need to modify this single formula in D1, for instance, plus 20. All the values in the range have changed. Plus 30. All the values have changed. If we want to delete the values, we just need to remove this single formula. Let's look at another example. In column E, we write some random numbers. 2, 3, 4, 5, 6, 7. Same for column F. 1, 2, 1, 2, 1, 3. Now in column G, we want to calculate the difference of the 2 columns on the left. How could we achieve this usually? In G1, equal E1 minus F1, enter. Copy select, paste. Here you go. The values are correct, there is no problem. After the release of dynamic arrays, we have another solution. In H1, enter equal E1 to E6 minus F1 to F6. Enter. We see that the range H1 to H6 was filled in with correct values. How is this formula calculated? First, it calculates E1 minus F1 and writes it to H1. Then it calculates E2 minus F2 and writes it to H2, and so on. So the formula of H1 takes two ranges, iterates them simultaneously, calculates the difference of each pair, and gradually puts it into the result set, and writes the result into the range H1 to H6 in the end. Now let's look at a sample with the VLOOKUP function. First, let's prepare the data. A, B, C, D, E, F. 1, 2, 3, 4, 5, 6. Here is a table. Here we write some random letters. B, D, E, C. Now the task is to find the corresponding value for B, D, E, C in the table J1 to K6. So a common way is to write equal VLOOKUP M1 table J1 to K6 to false. Enter. It means look for the exact value of M1 in the first column of the table and return the corresponding value in the second column. Then we copy, paste this formula to the other cells. We find the corresponding values for D, E, C. Now, how could we solve this by dynamic arrays? In O1, enter equal VLOOKUP M1 to M4 table G1 to K6 to false. Enter. Then the formula finds out the corresponding value for all the 4 cells. How is the formula evaluated? Well, first it evaluates the VLOOKUP of M1 against the table J1 to K6. Then it evaluates the VLOOKUP of M2 against the table J1 to K6, etc., etc. All these single values are put together to form the result set, which is finally written in the range O1 to O4. This new kind of VLOOKUP is more practical than the traditional multiple VLOOKUPs, isn't it? Now let's explain some specific terms. First, array is a data structure consisting of a collection of elements. It's a very common concept in all the programming languages. For instance, in this formula, B1 to B6 is an array. The values it points to are 1 to 6. It's a one-dimensional array that has 6 rows. Unlike B1 to B6, 10 is not an array, it's a single value. Additionally, the value that this formula returns, 11 to 16, is an array as well. As it cannot be placed in one single cell, Excel returns it to the neighboring cells. For example, in this formula, E1 to E6 is an array. F1 to F6 is an array. The return value of their difference is also an array. In this VLOOKUP formula, J1 to K6 is a two-dimensional array which has 6 rows and 2 columns. M1 to M4 is a one-dimensional array which has 4 rows. 2 and false are single values. Note that under some situations, a single value could be converted to an array containing only one element. Now the behavior we define is called spill. Spill means that a formula has resulted in multiple values and those values have been placed in the neighboring cells. Note that it's not a bad thing. So here the formula D1 returns an array, it spills down to cell D6. The range where the return value is placed is called spill range. When you select any cell in a spill range, you will see a blue border around that. Here the formula H1 returns an array, so it spills down to cell H6. H1 to H6 is a spill range. As the formula will spill, we need to reserve a blank space for the spilling. If there is any blockage, for instance some random texts, an informative spill error will be raised. Remove the blockage, then the formula will spill as expected. Spill error, no error. The next term we explain is the spilled range operator hash. Here we could write equal D1 to D6 to reference the range of D1 to D6. We could also write equal D1 hash to reference the entire range, where hash is the spilled range operator. The formula D1 returned an array and spilled. Thus D1 hash references the entire spill range resulted by the formula D1. That is how hash works. What if we write equal C1 hash? As the formula of C1 returned a single value, it didn't generate a spill range. C1 hash references only to cell C1. Also, we note that equal D2 hash doesn't work because cell D2 doesn't really have a formula. Its value is determined by the formula of D1. Instead, equal D1 hash should work. So this range we just created is a spill range as well. We could well reference it here by equal H8 hash plus 100 and make another spill range. Then reference it here equal I8 hash plus 200 and make another spill range, etc., etc. Therefore, we could continuously make spill ranges and reference them. It's very practical, isn't it? Now let's discuss what's the essence of this dynamic arrays. Let's recall what's the behavior of the same formulas in older versions of Excel. Here I'm using Excel 2013. In cell C2, we write equal B2 to B7 plus 10. Enter. It returns 11, which is a single value rather than an array. In cell D2, we write the same formula equal B2 to B7 plus 10. Enter. It returns 12, which is also a single value, but it's oddly different from what we got in C2. Let's type the same formula in E1. Enter. This time it returns an error. To sum up, in older versions of Excel, many functions such as addition, subtraction, multiplication, division expect single values as parameters. If we pass an array as a parameter to a function, the way the function works on it is not very clear. The return value of the function is always a single value, which is placed in one single cell. But it's not impossible to ask functions to better deal with arrays. We need to proceed as follows. First, we select a range. Then type equal B2 to B7 plus 10. Then we need to press Ctrl-Shift-Enter. We see that it returns an array which is written into G2 to G7. In the formula bar, we see that the formula is surrounded by curly brackets, which means that it's different from normal formulas. Let's see another example. Here we select the range. Enter equal B2 to B7 plus G2 to G7. Ctrl-Shift-Enter. It returns an array whose size is always the size of the selected range. The formula is also surrounded by curly brackets. The values are correct. In older versions of Excel, this kind of formulas are called array formulas, or Ctrl-Shift-Enter formulas, or CSE formulas for short. Today, we call them legacy CSE array formulas because of the newly introduced dynamic arrays. Array formulas have existed in Excel for more than 15 years. It's an advanced concept and skill of Excel. It's often an important criteria in evaluating Excel experts. As array formulas are quite hard to write and understand, not many Excel users have heard about them. For these users, the good news is that they could directly enter the easy mode today and learn dynamic arrays. Today in Excel, it's not necessary to press Ctrl-Shift-Enter to ask functions to handle arrays. Today, by default, Excel is in dynamic arrays mode. Excel uses now a calculation engine supporting dynamic arrays, where all the functions, including addition, subtraction, multiplication, division, became more powerful. Previous ways of receiving single values as parameters or returning single values as results is still kept. Moreover, now, if you pass an array as a parameter to a function, the function will try to interpret and evaluate. If the evaluation result of a formula is an array, formula will try to return it and spill it into a range. In this new mode, the formulas that could receive arrays, evaluate arrays, or return arrays are so-called dynamic array formulas. From the perspective of the design of programming languages, all these upgrades and changes of handling arrays in Excel can be concluded in one sentence. In Excel, array became native. It means Excel deals with arrays as natively as single values such as numbers and texts. If there's only one thing to remember from this lesson, it is array became native.